can totally hear everything you guys say. Like,
Was there
almost
anything
suspicious.
bad?
No. I was just shocked. The sound is different than on the Google Meet recording. Yeah.
Well,
anytime
anybody was on here, they would be complaining about me because I was loud on the Google Meet.
Yeah, it's the same.
So
on
I
the-
apologize.
I
apologize.
I would say it's even more so on this screencaster than the other. Okay, anyway.
He wasn't complaining.
I did pay for the
Yeah.
better version of this because this is what I'm stuck with for the rest of this school year until we get the better version of Google Meet. This is what I'm stuck with. So I paid for the better version, which allows me to record longer periods. So like the last class, it chopped it off at like 15 minutes. And sometimes one problem takes 15 minutes in this class. So I paid for the extended version. So here we go. What is a shell? Well, I'm going to try and do my best at drawing a shell. Think of it as, like I said, the peel of something. I'm going to put it on its like side though.
Oh my god. That looks like a combo.
So it's hollow. You think of this kind of like a washer, but it's not because a washer is thin.
Mm-hmm.
That was another story.
Really? This is saying worse or
Everything you
everything.
say. Okay, so let me put some labels on this picture. I know it's on its side, but we're going to call that H for the H. In this case, the axis of rotation would be going through the center. We're going to call this here, this is W for the width of the shell. And then we're going to call this letter here P. Width. P is the average radius. Okay, so we're going to use geometry. We're going to find the volume of a shell, just using geometry. Okay? Is that average radius? Yeah. So let's label outer radius and radius. Okay, so if we label P, just a random letter, I know, but P is the average radius of the shell. Average is the middle, right? The shell has a thickness. I know I've exaggerated the thickness to think of it, it's kind of thin. Because, like I said, if you were peeling an apple, what that volume would be. So, if P is the average radius, what would the outer radius be? We're going to say that's P plus half of W. Because W is the width of the shell. So it would be going out to the edge, and the inner radius would be P minus half of W. Does that make some sense? Outer would be the plus a half W, and inner would be the minus half W.
Wait.
Okay. Alright, so let's find the volume of the shell. Again, this is geometry. We're going to use the volume of a cylinder, right? This is a cylinder essentially. So it's pi r squared. The outer radius is P plus W over 2 times H. That's the outer. Now I have to subtract off the inner. Sorry, it kind of looks like it goes up high.
If you're writing it tiny.
Yeah. And that's
The
it. That
first
was
part's
kind
the
of
outer?
complicated, right? Like the outer shell minus the inner shell is the volume of what's left. Okay. So I just put W over 2 instead of 1/2 W. It's the same thing. But if I simplify this, we all know can FOIL, right? If I FOIL this out, I have p squared, I have another p squared, right? I have 2p squared.
Mm-hmm.
But the inside and outside, I have a plus pw, and over here, I have a minus pw. Do we not like actually write that out?
Yes, please.
Okay, so I have p squared plus pw plus w squared over 2.
Wait, so what is that for again? That's the thing expanded, right?
That's that.
If I
If
square
I
it.
FOILed it out.
Yeah, that's
Yes.
what I meant. That means square root.
FOIL it out, you get p squared, right? And you get this squared. And the insides and outsides would be pw divided by 2, but you have 2 of them. So it would be just pw. If I FOILed this one out, I would get p squared. I would get a minus pw. And I would get a plus p or w over 2.
Thank you for writing that out because that is.
What I'm going to do is just cancel a bunch of stuff because when you have a plus and a minus, see how this is subtraction? What's going to cancel out? They're both times a pi and they're both times of h, right? So we can kind of pull that pi out. We can pull that h out. I'll put them in a different order here in a second. So I have just this minus this. What's going to happen to the p squared? P squared minus p squared. Cancel. Or that's PWs. PW minus and negative PWs. 2PW. And what's going to happen to the W over 2 squares? So this is our equation for the volume. So, you see anything squared there? You see 2, a pi, a h, a p, and a w. So what all this means is that it's actually a simpler equation than using the pi r squared and pi r squared. Let me write it down in terms of a vertical and a horizontal axis.
Where's the
We'll do anything. The h came from, see how this has an h and this has an h? I just pulled it out in front.
Why do those two not cancel out?
They would, because there would still be an h left for both. Like, I just factored it in front. Like, if I distributed it to everything, then I would just have this times this, this times this. It would still be there. Because you could distribute it if you wanted to. And you would just have this pi h times this, and this pi h times this. It would still be there. I usually don't put it in that order. So the order I usually put it in for an integral is the 2 pi first, and then p h w. So I usually write it in that order, and you'll see why here in a second. So I'll go to the next slide before I do this.
Wait, so that's.
So the width of the shell is like the same as the width of the washer that we did for disc washer method. That W is just your dx or your dy. Okay, the P would be the distance from the origin or whatever the axis of rotation is, and then the H would be the height of the shell. So I'm going to explain that here. Anybody need more time to write it down? Okay. So we can have a vertical axis and a horizontal axis. But let's just remember that if you do a horizontal axis, it's a dy. For a vertical axis, it's now a dx. Now, I will say, in my own personal opinion, I prefer to do dx's always. Why? Because most of your functions are in terms of x, right? If I always choose a dx, then sometimes I'm doing the shell method and sometimes I'm doing the disc washer method. It just depends on your preference. If you like the shell method, then you can always use the shell method. But sometimes the shell method is harder than the disc, and then other times the disc method is harder. We'll do a comparison tomorrow so you can see. But this is what it would look like for the volume. You have your 2 pi. You know how in the disc washer method we just had a pi in front? Shell method has 2 pi. It's a different equation. We have our, well, let me just draw. horizontal axis, we have C to D. Yeah. See how we're using a dy for horizontal axis. Think of your shells as going this way. So the shells are actually parallel to the axis of rotation. Make some sense? Yeah, okay. So this is like your dy, your width. Okay, so what goes inside here? Well, this function has to be a function of y. So it would be like, we'll call it p of y and h. Now, p of y is usually just y. Because we're going to say, okay, this is a height of y. The only time it wouldn't be y is if we were rotating around a line like up here. If we were rotating around the line like way up here, it might be 10 minus y. It's always just y. Same thing for the vertical. It would be of x, and it would just be x. Now, h of y is this distance here. H of y. The height of that shell. And in this case, so it would be this function on the right times the function on the left. It'd be like finding area. You know how you did right minus left or top minus bottom? That's what it is. There's no squaring in here. It's just subtraction. Okay, let's set it up vertically. Same thing. We're revolving around this axis. So our shells are now vertical. Near the x. Volume would equal 2 pi. We're going to integrate from
A to B.
A to B. And again, I know it's a vertical axis of rotation, but it's a dx. And then our p of x is probably just going to be x. P of x, I didn't draw it over here. P of x is this, I'll do it in here. P of x is the distance from here to here. And here to the h of x. So it would be p of x times h of x. Alright, let's actually set one up. So we can see. I'll label this over here, but this here is your p of y. Again, p of y is usually just y, and p of x is usually just x. It's x distance from you, unless you're rotating around a different line. Okay, so this example. Does anybody have any questions before we do the example? I'm going to do one main example, and then, like I said, we'll do a comparison tomorrow. I think I wrote it down for Thursday, but I meant to put it on tomorrow. Okay. I'm going to give you a function, y equals 1 minus x, and x equals 0, y. So let's draw it. I should have drawn it bigger. Here we go.